Howdy ho, neighbor. We just did some cleanup to our app. Instead of describing all of those changes here, I recommend that you check out the Part 11 video, or alternatively, you can check out the written series, which is always linked in the description. As there were a lot of changes, you may want to check our GitHub repositories branch called Lesson 11 to make sure you have properly updated all of your code. We're in for another big tutorial today, but at least we've already put in place our desired architecture. Hopefully, the patterns we established while learning to sign up users will become even clearer as we learn to store tokens. Right now, I've opened up a diagram that we've previously looked at, but I've added check marks and grayed out the lines to components and connections we've already created. We recently implemented signing up a user from the perspective of a user service. However, what we didn't implement was the ability to store refresh tokens. We added this token repository with a new pair from user method, but we did not add any link to a repository to store these tokens. That's what we'll work on today. We'll add this set refresh token method and delete refresh token method, which both access a data source, which is a connection or a client connected to a Redis Docker container. But this raises the question, why should we store these tokens at all? The short answer is, this gives us the ability to invalidate a user's long-lived refresh tokens. Here I've opened up a diagram that we previously looked at. Recall that we set the duration to expiration of our refresh tokens to be 3 days, which you can see here in the token signing section of the account application. This allows a user with an expired ID, or sometimes called an access token, to reach out to this account application with their refresh token to get a new ID token. And that's what we're showing here. A request is sent with the refresh token saying, hey, my ID token is expired, and a fresh token pair is returned. Basically, at the end of the day, this makes our application user experience more pleasant. It means that the user will not have to authenticate with a valid email and password every 15 minutes, but can instead send this refresh token if they reuse the application within 3 days. However, there is a danger in creating a token that lives for 3 days. If the token is stolen, or let's say if the user wants to sign out of all their devices, they could still access the application for up to 3 days, unless they for some reason manually decide to delete the tokens from their browser storage out of the goodness of their heart. How will we address this? I'm now showing a diagram showing some, if not all of the ways we'll manage refresh tokens inside of a repository. We're going to create a Redis database to store valid refresh tokens for a user. We use Redis because it's a simple in-memory database, which means it's fast, and it allows us to easily remove the tokens from the cache or the database after 3 days. We might call this sort of list of tokens a whitelist. When a user authenticates and they receive a token pair back, meaning an ID and refresh token, that refresh token will always be stored inside of Redis as shown in this bullet point. We store the refresh token prefixed with a user ID and a colon inside of Redis as a key, and Redis easily allows us to set an expiration time called a TTL, or time to live. What we'll then do if the user wants to request new tokens, that's this tokens request. This is the case when their ID token is expired. We'll send the valid refresh token that hasn't expired yet, and we'll parse that and extract the JTI key from the JSON web token. We'll then check inside of Redis for a key matching that which we stored, which is the user ID, colon, and the refresh token ID. If the refresh token is there or it's valid, we'll then delete the previous user ID, colon, refresh token key value pair from Redis and create a new refresh token. Basically, say you have 2 days left on your refresh token, it's still valid. When we send for a new token pair, we'll get a refresh token again with a 3-day expiration time, and then we will invalidate the previous refresh token so that it's no longer usable. Then, of course, we send this ID and refresh token back as JSON. I think I'm repeating myself. Later on, we're going to also create the ability to sign out of all devices. How this works is the user will send their ID token to a post signout endpoint. The ID token contains the user's ID, and we can scan the Redis in-memory database for all keys that start with user ID : and then we can delete all of these. That will allow the user to sign out of all their devices, and this could also be used, though we won't add this feature, to reset a password, for example. Then, if you're logged in with a TV or your phone or some other device, you will not be able to log in. I note here that we'll be using a non-blocking scan operation, and this is something that Redis and the Redis Client supports. It basically means, say if the user has a bajillion tokens in Redis, which hopefully they don't, that the operation of deleting all of these keys will not block other operations from occurring. Now, I'll admit there are probably more infrastructurally friendly ways to store refresh tokens, but I think we will learn a lot by doing it this way, and you can adjust the approach to meet your needs. While we're on the topic, I see that many people create a blacklist of invalidated tokens as opposed to a whitelist of valid tokens. If a user wants to reset their password or log out of all devices, then all of their current refresh tokens are transferred from the main database to something like Redis. This may be a better architectural decision in your case. You'll likely save money using this technique, as you should be storing fewer tokens inside of Redis, and I think Redis is generally more expensive than a traditional database. But I think the overhead of storing tokens in your main database might add a little complexity, though it shouldn't be overwhelmingly difficult. Let's now just review what we're going to cover today, and again, a very long tutorial. First, we'll need to create a Redis container as shown in the data sources here inside of Docker Compose.yaml. We'll then need to instantiate a connection inside of our data_sources.go file in package main. So that's what this is all showing. We'll also need to add a token repository interface to our model layer. This is where we'll specify the method signatures for set refresh token and delete refresh token. So perhaps I could have added the interfaces to this model diagram. I'm too lazy to go update that. I hope you understand. The next thing we'll do is update our new pair from user method of the token service so that we can store the user's current refresh token and delete their older refresh token. In other words, we'll reach out to these two methods. We'll then need to update our unit test for this new pair of user, and in order to do so, we'll need to create a mock of this token repository. Then we'll actually create the concrete implementation of a token repository that uses the injected Redis connection to store and delete a user's refresh tokens. We then inject this token repository into the token service, and our application should then be ready to run because we've already injected this token service into the handler layer, so it should be ready to access from inside of our HTTP handlers. So let's do the first thing, which is to go to the root folder and to the docker compose.yaml file. Let's now add the Redis container definition. I'll scroll down to Postgres account, and then just below it at the same level, the level of our services, let's copy and paste the definition of Redis account. We'll use a base image of Redis Alpine, we'll use the default ports, and then we'll create a volume called Redis data to store this data. We then need to create this volume at the bottom of the file. So we scroll down, and at the very bottom we have volumes. Let's add a Redis data volume. The only other thing I can think of to do here is inside of the account application, we have this depends on, which is an array of other containers that this account service or container depends on, and we need to add Redis account to this. Let's now go to our package main and make sure we can establish a connection to our Redis container. First, let's open up data_sources.go. Recall that we have this init data sources function, or initds. We also have a struct that contains the various data source clients or connectors that we'll be using. We need to add Redis to this. Let's add the proper Redis package to our go.mod file. In the terminal here, I'll use go get and make sure to get go Redis version 8 as seen here. Let's then go to the data sources struct and add a Redis client field with a reference to a client which we'll establish. One thing to note is if you use auto import, you might not import the V8 proper version of the Redis client. So make sure to go here and add V8. You may have to prune or whatever the term is to remove that unnecessary import from GoMod. We will not worry about that right now. Let's scroll down in initDS. Here we establish a connection to Postgres and we ping, and then at the end we return data sources. So just before that, let's add some code to connect to Redis. We'll take a similar approach as we did for Postgres. We'll read in the Redis host and the port from environment variables, which we've yet to set. We'll set those shortly. I then do some logging and I use the Redis new client method with the options of the address, which is just the host separated by a colon and the port. These are the values we read in from the environment variables. We don't need a password in this case. And then we will ping the database just to make sure we have a connection and that there's no error. And finally, we'll return the data sources struct, but now with the Redis client. And I copied and pasted over. We no longer need this return statement. And let's save that. I just scrolled up to make sure we're still using the proper Redis import. Inside of the account folder, we have this environment development file. Let's open it and add the key values for Redis. Here they are. And remember, for the Redis host, this environment file is used for the Docker Compose environment. Therefore, instead of using localhost to access the Redis account, we give the name of the service, and that name of the service is the same as used here in Docker Compose. So just make sure you do that. The default port is 6379. The last thing, as far as data source connection goes, is to close this connection inside of a close function or method actually that we have here at the bottom. We first close the connection to Postgres, and we'll do virtually the same thing for Redis. We say D, meaning the data sources. We check the Redis client close method. If there's an error, we'll log it. Let's now change directories into the root directory. Right now I'm in the account folder, which is one directory into the project. And let's run Docker Compose up and see if we get a nice log saying that we've connected to Redis. Here we go. There's the Redis account log. It says running. There is a warning I'll have to check out, but it looks like it's initialized, and we re-downloaded everything in account, and it looks like we've connected to Redis with no errors. Excelente. Let's move on to defining the expectations for our token repository. We can do this inside of the models layer in the interfaces file. Let me close the other files. They get in the way, and let's open interfaces. This is where we define the expectations of what our services and repositories do. Let's add a token repository. Here is our, well, at least our partial token repository, and all of these are partial definitions. We'll go adding more methods later. For now, we want the ability to set that refresh token based on the user's ID and token ID and some expiration duration. We also want the ability to look up a user's ID and delete their older refresh tokens based on their previous token's ID, which I mentioned is extracted from the JTI key of the refresh token's JSON web token. Now, if that isn't a mouthful, I don't know what is. We then need to be able to access a token repository from inside of our token service implementation. Currently, this service has a single method called newPair-from-user, which will use the repository methods we just created. Let's go to the service layer and token service. And here is our only method in it so far, newPair-from-user. Recall that in this method, we generate an ID token and we also generate a refresh token. We did this previously, but we're not storing them yet. The whole point of this tutorial. But to do that, we need to be able to inject a token repository. Let's do that now. And actually, I have it commented out here already. So let's just uncomment that. we'll add a token repository. This token repository needs to be added to the config because that is what our new token service factory accepts. Finally, just make sure to add a token repository field or field in value. And this will be :c.token repository. And add the comma and save. We're now ready to inject this token repository into our token service. We'll now scroll down and add the logic for accessing this token repository in the new pair from user method. We have a nice to-do comment here, and so let's add the code here. The first thing we do is reach out to the setRefreshToken method of the token repository, passing the user's user ID as a string in this case. This user is the user passed into this method from the handler layer. We then pass in the refresh token ID, and this is the refresh token generated in this line with the generate refresh token utility function. And finally, we pass in an expires value that's also on this refresh token. If we get an error, we log it for internal use in the log line here, and then we return a new internal server error. Then if the user is accessing the refresh token route, we'll check for that previous token ID, and recall this is passed into this method from the handler layer. If this previous token ID is not an empty string, then we reach out to delete the refresh token with that ID. Again, this will be implemented or actually used. It is implemented now, but it will be used inside of our refresh token handler. When we call this method from the signup or sign-in handler, we pass an empty string, so this line is passed. Or in other words, this block is skipped. Let's update our tests inside of tokenservice_test.go to reflect these changes which we've just made. But first, in order to implement these changes, we need to create a mock of a token repository. As always, we need these mocks to separate our application layers. Let's go to the model folder and the mock subfolder and add a new mock called token repository or token_repository.go. We've gone over these mocks many times. Basically, you create a struct and you pass the mock from the Testify mock library into it. And this just lets us track which methods on the token repository have been called, how many times, and with what parameters. To be able to do that, we have to set up the mock and basically define what return types can be returned from this method. For both of these cases, we only expect to receive a possible error when these methods are called. So you can look at these briefly and copy and paste this code if you'd like. We've done this many times. Let's go back to the token service test, where we need to make the following updates. We want to assert that the token repository's setRefreshToken method gets called inside of the current test. And the current test here is called returns a token pair with proper values. So we weren't reaching out to any repository before. Now we are, and we need to make sure that that setRefreshToken method gets called. Recall that this new pair from user method can also take a string, which is the previous token ID. Currently, we have nothing there, but we'll update this with some value to make sure that the token repository delete refresh token method gets called. And if we look at the service, that's this if previous token ID is not equal to empty string, we reach out to this method. We're going to check that. Then we're going to create two more tests. The first one will assert that the token service new pair from user returns an error if we have an error setting a refresh token. And the second new test we'll add will assert that the delete refresh token method is not called if we supply an empty string for the previous ID, and that's what we're doing here. So we'll change this new pair from user call, but then we will update it in another t.run test block. All right, enough talking without showing. Let's get this set up. For this test, I actually want to instantiate the mock token repository before the t.run blocks. Previously, we would instantiate a service or repository inside each t.run block, but I want to set up the mock for all of the tests in this setup section at the top. Let's maybe add that just below where we load our secrets and our RSA keys. We create that mock token repository with new, and then we make sure to inject it into our token service. And again, it looks like I'm duplicating code here. Let's remove that. Just before t.run, so if we skip over this creation of a mock sort of user, here I want to define all of our mock cases and mock arguments and mock method calls. So we were here right at UID. I want to create another user ID for the case when we have an error. And I also want to create a variable called previous ID, which will store that previous token ID. It doesn't have to be anything specific, as this will just be used in a mock. So I just provide a non-empty string. You might also notice that I'm doing something completely different than in previous test cases, and that is to define our arguments as mock.argument structs in the setup. So we have arguments for when we get a successful response to our method call. We have arguments that will be passed when we get an error, and we're just going to use that different user ID. And then we have a set of arguments for when we provide the previous ID. Then we set up our mock method call responses. So if we call the set refresh token on the mock with the success arguments, and we spread these into a parameters with the ... we want to return nil. If we call with the error arguments, we would just want to return a simple error string, error setting refresh token. And if we call the delete refresh token method with these arguments, we return nil. Let's now make some updates to our first test. So first, I want to use context background here. And you might remember in other unit tests, we're checking if a mock is called with a context empty context. And that's the type that's returned by this context.background. So to be consistent with our previous tests, I want to change this to context.background. I just want to add a little comment for that change here. We'll also change this empty string to prev ID here, and that we set up in the setup before the t.run block. Let's add a comment for that as well. And so this is for anyone who was looking at previous code. Aside from asserting that no error occurred, we need to make sure that our set refresh token and delete refresh token methods were called with the proper arguments, as we can see here and here, I think. Let's add them below. So we make sure that the set refresh token method was called with the set success arguments, and we make sure that delete refresh token is called with delete with previous ID arguments here. The rest of this test will stay the same. We checked a lot of details about the created JSON web token, and we don't need to make any of those changes. But we do need to add another test block for getting an error in creating a refresh token. This test will be a lot simpler. We'll just call token service new pair from user and pass in the user error case. This user error case was set at the top in the setup. And this just means that our method gets called with a different random user ID. And hopefully this one does not match this one. They shouldn't. The first thing we want to assert is that an error is returned from the new pair from user method. Secondly, we want to make sure that our set refresh token got called. This sort of indicates that this reaching out to the repository called the error. However, we want to make sure that our delete refresh token is not called, because if we go to our token service, if this returns an error, we're going to return from the function or method, and therefore we never get to this block. Finally, let's add a test for the case when no previous ID is provided, and we'll test to make sure that delete refresh token is not called. We don't really need to do anything else, as we've tested the response body and all that jazz in the first test. Again, we create a context background, and we call new pair from user, but this time with an empty string. We make sure that we don't get an error, and we assert that set refresh token gets called with set success arguments, but that the delete refresh token is not called because, again, this block is equal to an empty string, so we skip this whole if block. Let's now run these tests, and we can do this by shutting down our Docker environment with Control-C. And in fact, maybe, oh, that went fast. Let's just change directories now to the account folder. Before running these tests, I noticed that for error case, I am passing in, if we scroll up here, all the way up, I'm passing in a UUID. Instead, I need to pass in an entire user, so let's make that update. To make that update, we take this UUID, and then we pass it to a newly created user for the error case with the UID for the error case. Let's save. And that should fix our error. Now that I've fixed that user problem, let's go ahead and test this with, I'm going to use go test verbose flag, test the service folder or package, and then use this -run to only test the new pair from user method, as this will reduce unnecessary output. You can also just run go test and all packages to make sure nothing else is broken. And it looks like everything is okay. With our token service complete and unit tested, let's now implement the token repository. We start by creating a Redis token repository file inside of the repository folder here. The first thing we do inside of this repository is, as always, set up a struct to take the injected data source, which in this case is a Redis client, and remember to use v8 as shown here. And we'll create the factory, which will take a Redis client and just return the token repository. And we should get this error warning us that the necessary methods have not been defined on this struct. Let's go ahead and implement those set refresh token and delete refresh token methods now. Here are the methods. Let's save the file. First, we have a set refresh token, which takes a user ID, token ID, and expiration time. We then create a key to store in Redis. This key, if you recall, will be the user ID, and then the token ID. We'll then use the Redis client's set method to set this key, and we'll just put a value of an integer 0, and then pass in as well the expires in value. This expires in will be 3 days. It's very convenient that Redis can do this so easily. If there's an error, we'll log it and return a new internal server error. Otherwise, we return nil and assume everything went swimmingly. The delete refresh token method will do something similar. We'll create the key with the user ID and token ID, and then we'll reach out to this key to delete it using Redis's del method. I hope that's pretty straightforward. Any errors in this case will be internal server errors. Now that we have a concrete implementation of a token repository, let's inject this into our token service implementation. We do all of this dependency injection, if you can recall from about 2 tutorials ago, in package main in this injection.go file. And once again, I'm opening way too many files. Let's scroll up here to the top where we set up a user repository, and let's set up a token repository. Recall now that we have this new token repository method in our concrete implementation of a token repository, which can receive a Redis client, and we connected to Redis very early on in this tutorial, and this is on the D data sources. Next, after we instantiate a user service, let's also instantiate a token service. In fact, we already do that, but let's change this comment because this is the service layer. Here we instantiate the user service, and let's scroll down to where we already have the token service and make sure that we inject a token repository. Believe it or not, that should be all we need to do for dependency injection because our token service is already injected into the handler layer as seen here. Let's go to our terminal and let's change directories one directory up to the project root. Let's clear this baby and let's run the application one more time. It would appear that our application is working. I'm going to open Postman and rerun this signup route. Here I am in Postman. I am in a tab for signup, which uses our base URL malcorp.test, and then reaches out to post to the signup handler. Or perhaps I should say the signup endpoint, which reaches out to the signup handler. But we're getting our words tied up in a knot. I just deleted all of the users inside of the Postgres database. So let's go ahead and sign up guy01 again and see what happens. Great, we received our ID and refresh tokens. Now what I want to do is take this refresh token and I want to go to the jwt.io debugger and extract the JSON body from this token. Here I am inside of the JSON web token debugger. So let's paste this token. And remember that our keys in Redis are stored with this UID, and then this JTI, which is the token ID. What we're going to do is copy and paste these into our terminal and search for them using a Redis client. Let's open up another terminal window here. Inside of the root folder, I guess it doesn't matter here. And we're going to use redis-cli get, and then we're going to copy and paste the user ID and the JTI separated by a colon. If you do not want to use the Redis CLI, there is also a graphical user interface, actually a few graphical user interface options out there for free, but the Redis CLI is pretty easy to use, other than the fact that I need to type in this long key, which is kind of a pain. Let's hit enter, and we see that we have a value of 0 stored at that key, which is what we do in the concrete implementation of the Redis token repository. Great. Let's also make sure that we have an expiration time that looks to be about 3 days. To do that, I'm going to copy this key, and then I'm going to use the Redis CLI's TTL command, meaning time to live, to see what the time to live is of this key. And we see 259,037 seconds. If we go to our env.dev, we should see 259,200 seconds. So we're just shy of 3 days, which is how long it took me to copy and paste all of these UUIDs and token IDs. So we at least know that in practice, our storage of Redis tokens is working. So everyone, take a deep breath. That was a long one. I'm also going to have to do a lot of editing on that one, so sorry if the video is choppy. But for those of you who got through it, te felicito. Thanks for hanging around. We're starting to reap the benefits of our application's architecture. Sure, it was a pain in the arse to set it up, but now I'm quite enjoying connecting everything. Next time, we'll add middleware to set a handler timeout for each individual request. This tutorial won't involve modifying so many files. I think it will generally be much easier, but it will still be interesting in terms of working with the Go language and addressing concurrency principles. Anyway, hasta pronto.